Let's start off with some of our sneaky problems. First of all, tangent lines with parameters. Remember that a parameter is similar to a variable, except that it is a number. It's not varying at all, but it's represented by a letter. But the thing is that even though we don't know what number that letter stands for, it only stands for one number. So let's just say what a parameter is. And here's an example problem. The line 2k plus y, that's 2x plus y, equals k, where k is a constant. That means k is our parameter in this case. This line is tangent to the graph of y equals x squared. What is the value of k? Now, there are a couple of really key things to notice about this. First of all, we know that if we have this tangent line, that means the slope of the line equals the derivative of y equals x squared at some point. We don't know what that point is. I'm just going to put little question marks. But that's what we're trying to figure out. So let's start off just by figuring out what the slope of the tangent line is. Two x plus y equals k. To get slope-intercept form, we simply get y by itself, so negative 2x plus k. So that means that the slope of the tangent line is negative 2. Now, somewhere, for some value of x, we know that y equals x squared is also going to have a slope of negative 2. So let's figure that out. Remember, we're talking about the derivative. So if we start with the function y equals x squared, we take the derivative of that, that's 2x, and we know that at some point we want that slope, that y prime, to equal negative 2. Divide both sides by 2, x equals negative 1. So when x equals negative 1, we know that the slope of the tangent line is going to be negative 2, and the slope of the function itself is also going to be negative 2. So we're getting really close. Now we know x. We're trying to find k. So if we also can find out what y is, and we plug both those in, then we can solve for k. So what I'm going to do is I'm going to use this original function and this, substitute in. Y equals negative 1 squared, y equals 1. So that means that the tangent line 2x plus y equals k goes through the point -1, 1. So that means that we can use this, substituting for x and y, solve for k. And there we go. K equals -1. Let's do a check for understanding problem on that one. Let's say the line -3x plus y equals k, again where k is a constant, is tangent to the graph of y equals x squared minus 5x. What is the value of k? Go ahead and solve that one on your own. Restart the video when you're ready. Pause the video now. Okay, so once again we know this is a tangent line, so that means that the slope of this tangent line equals the derivative of this at some point. So here we found the slope of the tangent line. Now we'll work with the function. The derivative is 2x minus 5. So at some point, that derivative also equals 3. Add 5 to both sides. Divide both sides by 2. And now we've got our x. If we can find y, then we can find k. So y is 16 minus 20. Y equals -4. Now we can take both of those and put them into our original equation. So this is -12 minus 4 equals k. K is -16.